Welcome to another edition of ProSoft Technology video training. Today we'll be configuring a PLX32 EIP MB-TCP UA gateway to allow a SCADA on OPC UA, acting as a client, to request data from a control logics on an EtherNet IP network. The gateway will read data from the controller, and the SCADA will then be able to retrieve the data from the gateway's UA server. We'll also cover setting up a command to communicate with devices on Modbus TCP IP. On the dual EtherNet IP MB-TCP port, the PLX32 can connect to both clients and I/O masters as well as server devices. Here is a diagram that shows the IP addresses of the devices that we'll be using for this training. If you don't already have ProSoft Configuration Builder and OPC UA Configuration Manager software, you'll need to go to our website, download, and install them. In this video, we'll cover using ProSoft Configuration Builder, or PCB, to configure the EIP MB-TCP side of the gateway. Create a client command to read data from the control logics. We'll use OPC UA Configuration Manager to configure the OPC UA port, create the certificates we need to communicate with the gateway and the UA client, and we'll configure the server for unsecured or anonymous communication with our UA client. Let's begin. First, we will open up ProSoft Configuration Builder, or PCB for short. Right-click on the default module in the tree view and select Choose Module Type. In the product line filter, select PLX30, and from the drop-down menu, choose the PLX32 EIP MB-TCP UA and click OK. Now we'll assign an IP address for the gateway. Expand PLX32 EIP MB-TCP UA and go down to Ethernet Configuration, right-click and choose Configure. We have two ports. Port 1 is used exclusively for the EIP MB-TCP side of the gateway. This is where we set the IP address that we want the gateway to use for the EIP and Modbus TCP network. This is also the port that we'll be using to download our configuration here in PCB to the gateway. So I'll change the IP address to 10.12.1.242. Port 2 is used exclusively for the OPC UA applications, and this should be on the same subnet as your third-party UA clients that you'll be communicating with. This is the port and the address that we'll use to download our configuration to the gateway's UA server in the Configuration Manager software a little later. You'll want to set this to an available address on the same subnet as your third-party UA clients that you'll be communicating with. Also, we can change the netmask and gateway for each port. For netmask, you only really need to change it if you're going to use a netmask that's different than the default of 255.255.255.0. And for gateway, if you plan on going through a router to communicate with the device that would normally be restricted by your netmask, you would enter the IP of that router under gateway. I won't be communicating through a router, but I'll enter the IP of my routers into the gateway fields now, just in case I want to use it in the future. Once this is done, click OK. Now we won't need this for our configuration here, but I'll mention at this point that the PLX32 comes with an embedded EDS file allowing Rockwell configuration tools to identify the gateway. To access the EDS file, just open up RSLinks, select RSWho, expand Ethernet IP, and find the PLX32 gateway. It'll be an unidentified device. Right-click on it and choose Upload EDS from Device. Just follow the prompts to finish uploading your EDS, and the gateway is now ready to be integrated into your Rockwell programs. Next, we'll go down to SNTP Client. In order to create and sign all the certificates for OPC UA communications, our UA server needs accurate timestamps from an NTP server. Typically, you might connect to a public NTP server, and this means the gateway would need to be connected to a network with internet access. Alternatively, Rockwell Automation, Schneider Electric, and other PAC manufacturers have NTP server capabilities either built in or available for their controllers and EtherNet devices. You can contact your respective PAC manufacturer for more information. It's also possible to set up a Windows PC with NTP server functionality and point the gateway to that. For this training video, I've configured another PC on my network to act as the NTP server, so I will enter that IP address. Now I'll enter a command to read some tags from our ControlLogix processor. Go down and expand EIP Class 3 Client 0. We have presets for specific types of PLCs. For ControlLogix or CompactLogix, you should select Control Tag Access. I have a ControlLogix, so that's what I'll use. In the window that pops up, we'll add a row and edit that row. We'll start by enabling the command. Internal database will be 100, and this is where the data will be written to in our gateway. For register count, I have 20 values that I want to read in the ControlLogix. So we'll grab 20 words of data. Node IP address will be the address for the ControlLogix processor, and slot number should be the slot that your processor occupies in the ControlLogix rack. For function code, we'll select SIP data table read. Tag name will be the name of the tags that you want to read in the processor. I have an array of tags named MyData, so that is what I'll enter here. Offset is where you want to start reading in the array of tags. I'll just leave it at 0 to start reading from the very first tag in the array, and we can click OK. So our EIP command is ready. If you wanted to create this same command to communicate with a Modbus TCP device instead of a ControlLogix on Ethernet IP, it's the same basic process. We'll go down to MBTCP Client 0 and configure MBTCP Client 0 commands. We'll add a row and edit the row, and most of this is the same. You would enable the command, set internal database in our gateway, the register count, the node IP address. If your device uses a slave address, you would enter that, otherwise just leave it at 1. Select the Modbus function code that you want to use for the command. The Modbus address in device will be where you want to begin reading or writing data in the device. Note that our gateway uses 0-based addressing. So if you wanted to read from a Modbus address 40,028, for instance, you would enter 27 here. Then you would click OK and you're done. We'll go back to our original configuration. You actually can share data with devices over Ethernet and Modbus TCP simultaneously through port 1. You just need to make sure that you're writing to different addresses in the gateway's database so as not to have data from one command overwriting data from another. Even though the module has a default IP address that is not on our subnet, we can still download to it by assigning a temporary IP address using our ProSoft discovery service. So right-click on the module and choose Download from PC to Device. Once the window opens, choose Browse Devices. Now PCB will scan for any detectable ProSoft products, and in the window you should see your PLX32 gateway come up. Here we can assign a temporary IP that the gateway will use until the next time it cycles power. Right-click on it and choose Assign Temporary IP Address. And we can just use the same IP that we entered earlier since we know it's available. Click OK, and now make sure that the IP address is in the Ethernet field and choose Download to permanently set the IP address. Now we'll configure the OPC UA portion of the gateway. To do this, we'll open up the OPC UA Configuration Manager. We can do this from inside PCB by clicking on the OPC UA at the bottom here. If you don't already have that application installed, a message will pop up letting you know that you need to install it. When the UA Configuration Manager opens, it will detect that there's no existing project for this server, and it'll ask if you want to create a new one. I will do that. In the window that opens, we can give the server a new name and a description if you like. The IP address that we assigned to the gateway's port 2 is already there, so we can click OK. At this point, we should also ensure that our PC has access to this IP address space. The communication and downloading that we do in Configuration Manager will all be through the gateway's port 2 to our OPC UA server. So you might need to change your PC's IP address to something on the same subnet or physically plug into a switch on the new network. So I'll quickly go over the tabs at the top here. As you can see, the General tab shows us the selected gateway's name, description, and IP address. Status gives us a range of status info for the UA side of the gateway. This will populate once we've made a connection with the PLX32. Endpoint displays the UA server's supported encoding and security profiles for accessing the functionalities of the UA server. We'll come back and enable these a little later. Under Certificate, we can view and manage our certificates once we've created them. The Variables tab is where we'll set up the tags to make them available to the SCADA. And finally, we have the Access Control tab, where we can see the permissions for different user groups and the list of individual users. As you can see, we have some default usernames that correspond to each group, and you can manage the user permissions by assigning them to the appropriate group. We can also add or delete users, as well as edit the password for existing profiles. And we'll come back to this a little later. There is also an Advanced tab, but thankfully we don't need to do anything there. Right now, we're going to begin the provisioning process, and this entails creating the certificates that we will need in order for the Configuration Manager software to communicate and download to our UA server on the PLX32. Communication between the server and the UA clients will also not work without these certificates. Go to Setup in the menu bar and select Create Provisioning Application Instance Certificate. This will open up the Certificate Creation Wizard, and we're just prompted to fill in all the appropriate information. You can keep the default name or give it something unique, and as you can see, there are fields for organizational and location information. You can fill it all in or leave it blank. Nothing you enter will affect the certificate. The validity period is 5 years by default, and you can adjust it up or down depending on your security requirements. If you have no requirements, you can just click the Set to Latest button to set the expiration date out as far as the software allows, which is just over 24 years. Hopefully that will be adequate. When you're done, click Next. And our new provisioning application instance certificate will be generated and saved. Now remember that you must have a proper source of timestamps in order to complete the process of provisioning the gateway. When you do connect to the gateway for the first time, you'll need to log in. The default credentials are username, admin, password 12345. Sounds like the combination an idiot would have on his luggage. So obviously you'll want to change your login info before you finish the configuration. We're going to be asked to log in a lot as we go through the configuration, so you might want to save your login name and password for this session. Once you log in and connect to the gateway, the information on the Status tab should populate, and this would indicate that the Configuration Manager can communicate with the server. We'll carry on creating our certificates, so go back to Setup and select Create CA Certificate. This is the certificate we will ultimately share with the client to enable communication. As before, fill out the information and click Next. The certificate will be generated, and we can move on to the Application Instance Certificate, which is the final certification that we'll need. The process is the same as before, and once that is complete, our certificates are all in order and we can move on to the next step. go to the Endpoint tab. To ensure that we have all the options that we need for anonymous communication, I'm just going to enable all of the profiles here. We'll go ahead and download this to send the changes to the server. Now you'll also find download buttons on several of the other tabs here. These only apply to the respective tabs. These download and upload buttons only affect the endpoint configuration. So this means you'll need to download any changes you make on each tab separately. You can ignore the warning about the default login information. We'll be changing that in a bit. Next, we'll click on the Certificates tab. We'll start by clicking Create and Sign New. This will apply our security profiles to the CA certificate. So we'll connect to the server, and when it's done, click Next. For certificate type, we want to select RSA 128. This will allow us to communicate without security. So we'll go through the certificate creation process yet again, and this may take a minute to complete. And when it's all finished, we can click on the View Export button, and we can see all the security profiles, including at the top, no security, that we have available. We're now ready to export our CA certificate to the client. So click Manage Trust Lists, and this will open the Trust Lists Editor window. Our CA certificate should be right at the top here. Select that and click Export. You'll need to export it to your client's Trusted Certs folder. I'm using a client simulator for this training, so your path will be different than mine. It might be on a network drive, for instance. If you aren't sure where the Trusted Certs folder is, talk to the person who set up your client. When you find it, save the certificate there. Now we need to import the client driver from your client system. Click the Import button, and the file we need should be in the same folder system where we placed our certificate, probably under Own Certs instead of Trusted Certs. Again, consult the person who set up your client if you're not sure. When you find it, select it and click Open, and it should appear in our Trusted Certificates list. Next, we need to export our Certificate Revocation List, or CRL, to the client's Trusted CRL folder. So make sure you have the CA certificate selected and click on the Revocation List tab. Now we've just created our CA certificate, so our revocation list is empty, but it's used to keep track of all the certificates signed by our CA that have been revoked or expired. We can now download this configuration to the server. Once it finishes, we can close the window and go to the Variables tab. Here we can map the tags that we set up the command for back in PCB. So click Add, and a window will pop up where we can define what variables we want to make available to the UA client. Now if you only have one variable that you want to address, you can enter whatever name you want and move on, but if you have more than one, just hold your mouse cursor over the name template field, and instructions will pop up showing how to format the name for a group of variables. In my case, I have 20 16-bit words that I want to read, so I'll enter a name _% 02D. The 02 here means that the array will be displayed with 2 decimal places for the number of elements. If you entered 03, like in the example, it would be displayed with 3 decibels, which also works. It's up to you. And I'll set the number of variables to 20. Under data type, you can see all the data types that we have available. I'll just select integer 16. Offset in words will be 100, and you'll remember that's where we set the data from the ControlLogix processor to be written in the gateway's memory. Finally, we'll enter a folder name where our array will be located. We can click OK, and our variables have been added to the list. Now once the SCADA accesses our server, the variables will appear in this folder as an array of 20 individual tags. So it will be myTag _1, myTag _2, and so on. So go ahead and download the new variables. To finish up, go to the Access Control tab. As mentioned before, we need to change the default password for the admin account. I'll do that now. Just select Admin under the user list and click Reset Password. The new password must contain one of each character type listed here. Make sure to keep track of your new login. Next, to use anonymous communication, we'll actually be using the anonymous user account, and we need to assign it to a group in order for our server to accept communications. Select Anonymous in the user list and add it to the operator group. Just select the group and the user and click Add to Group. Now, for security, you should also move the default user profiles for operator and user from their respective groups. You can add them to the disabled group. Now, if you ever wanted to use these profiles in the future, you can simply assign them to the group with the permissions that you need. Click Download once again. And if it does ask you to log in, remember we're still using the default login at this point. Once this download completes, our new login information will be in effect. Now, when I go to the Status tab, I can use admin and my new password, or I can enter anonymous with no password. Now, as an operator, we can access the configuration of the server, but we can't make any changes. Now is a good time to save the project. We're now ready to communicate with the SCADA system. Again, I'm using a UA client simulator here, so your connection process could be quite different. In your OPC UA software, you would just enter the address of our UA server and select the unsecured profile, and our data will be under the folder that we created to hold the 20 tags. That is a fairly quick overview of how to configure the PLX32 EIP MB TCP UA gateway. We hope that you found it helpful. If you have any questions or would like more information about the product, use the link in the description to go to its product page, or feel free to give us a call. Until next time, happy training.